synthesis of ether has been discussed in the different parts of the chapters that we have discussed already. So there could be more, but let me summarize some of them we discussed. Let's say you have a double bond, and then you could do something like this. You treat the mercurium diacetate in a little bit of water. Then what happened was, the mercurium diacetate dissociate, that makes a mercurium ion, and that's a Lewis acid. The nucleophilic pi electrons makes an attack. But because the mercury is huge, it's not just going to be bonding with one of the carbon. It's actually going to be hovering with both carbon at the same time, making like a cyclic mercurium ion. And then mercury is going to possibly charge it. That's going to pull it to density from those two carbon bound two. But the more substituted carbon will lose molecular density, and that's the water molecule makes an attack, backside attack, right? And that's going to have placed an oxygen, OH here, and the mercury on the less substituted side. So this step is called the oxymercuration. And then what happened in the next step is the sodium borohydride will reduce the mercury just by giving electrons. So mercury is going to reduce the mercury metal and just replaced by the hydrogen, so you can make an alcohol. This is not ether yet. What I'm saying is, of course, in double bond, you can make an alcohol there, but using that alcohol, you can do the Williamson ether synthesis, which is nothing but starting with an alcohol, you deprotonate the hydroxyl groups of alcohol by a base, strong base, like a sodium hydride or a sodium metal. That will make an alkoxide as a nucleophile. And if you treat it up, you have like photosynthesis. And it's going to make an SN2 reactions. And that way, you are creating ethers. So that is a Williamson ether synthesis. You can start from the alcohol, but if you don't have an alcohol, you can use a double bond. You can do the oxymercuration, demercuration. You can do the hydroboration if you want to. And those type of reactions that we've been talking about, chapter 8 and 9 and 6 and like that. But there's a direct way, kind of a much faster way to make this happen. There's the same molecule, you do the oxymercuration, but not doing in water, you're doing in alcohol, then something called alkoxymercuration happens. The same mechanism, the mercury will be attacked by the molecule with high electrons. It's going to make the mercury divide. But instead of the water, if you have an alcohol added there, alcohol is going to make an attack, opens it up. So you've got the alkoxide already placed. You don't have to go through the Williamson ether synthesis this way. Of course, the mercury still have to be removed by the second step. The sodium borohydride, reduce that, and you can produce the same thing by the alkoxymercuration, demercuration. And the former one is called the oxymercuration, demercurations. And then this one's called the Williamson ether synthesis. So things like that is what we have talked about.